question 8 is another experimental one. This is another of the required practicals. This is looking at different insulating materials. So what we've got here is a student who's investigated the properties of 3 types of insulation, and they've used the apparatus shown to do that. So on the left hand side we've got a hot metal plate that's being kept at a constant temperature. There's a temperature probe connected to that hot metal plate, so that should be registering the same temperature all the time. And then to the right of that hot metal plate we've got some insulating material, which also then has a temperature probe attached to it to measure the temperature on the other side of the insulation. Okay, so that's the situation. Let's take a look and see what's going on. So we've looked at some different insulating materials. So we've changed the insulating material that's attached there, and we've measured the temperature on each side of the material. Okay, we've used data loggers to keep a track of those temperatures. Okay, so what we've then got is a graph showing what we got from the second temperature sensor that was connected to the other side of the different insulating materials. So we've got material A, material B and material C, producing those 3 different graphs of temperature. Okay, so 8.1 is asking us what was the temperature of the hot metal plate. Okay, so we're going to have to look at the graph to work this out. Okay, remember the hot metal plate is being kept at a constant temperature. Now, what we can see here is that material A starts off at 20, but then rises up and reaches a constant temperature of 80. Okay, neither of the other 2 materials reaches a constant temperature, neither of the other 2 gets as high as 80. So the conclusion from that is that the hot metal plate must be at 80 degrees. Okay, that is the only thing that makes sense there. Okay, 8.2, which material is the best insulator? Remember, the point of insulation is to reduce the amount of energy being transferred. Okay, so material C has done the best job there. Okay, it is the one that has heated up the least. It has only got up into the high to mid 40s. Material B has got up into the early 60s, and material A has got to the same temperature as the metal block itself. So we need to put a tick into block C, and then we need to give a reason for our answer. Okay, so very simply, after the 10-minute period of the experiment, C had the lowest temperature. Okay. And in part 3, another student repeated the investigation but doubled the thickness. So the same 3 insulating materials were used, but this time there was a double thickness of each of those materials. Okay, what we've got to do is suggest how thicker insulation would affect the results of the second student's investigation compared to the first. Okay, because the layer of insulation is thicker, it's going to take longer for energy to transfer through it. So a key feature of the second investigation would be we'll be seeing smaller temperature rises for all 3 materials. Okay, but then we need to explain that. Okay, so for all 3 materials we see a lower temperature rise than we saw in the first experiment, because with that double layer of insulation we have reduced the rate of temperature change. Part 4. The student could have used a thermometer instead of temperature probes and a data logger. Okay, so we've got a little graphic there to illustrate what's going on. So on the left hand side we've got the data logger showing its display, and then on the right hand side we've got a thermometer and then a little blown up view of what we'd read on a thermometer. Okay, we have to give two advantages of using the data logger and the temperature probe compared to the thermometer. Okay, now the first advantage to the data logger is it has a higher resolution. With the data logger I can easily see whether it's 38.7 or 38.8. I can read the data logger to 1 decimal place. Okay, whereas if I look at my thermometer, if I look at the blown up view, I can see it's between 38 and 39, but there's no way I can tell it's 38.7. So the way of expressing that is to talk about the resolution of the instrument and to say that the temperature probes have a higher resolution. They are more sensitive. Okay. Also, there's a much smaller risk of me misreading. Okay, if I look at my thermometer and I'm not at the same level as where the top is there, if I was looking at that level there, I might get it right, but if I was looking down there or if I was looking from underneath, I might not read the thermometer correctly. Whereas the data logger, it's fairly unambiguous, there's much less risk of misreading. Okay. And then final part of this question, we've got a table of information, 4 different types of insulation, and we've got their thermal conductivity. Okay, so what we've got to do is to explain which one of the types of insulation would be the best to use for cavity wall insulation. Okay, now what we're looking for is the lowest thermal conductivity. Okay, so the one with the lowest thermal conductivity is the polyurethane foam. Okay, because if it's got a low thermal conductivity, that means it's going to have the lowest rate of energy transfer.